All right, what's up, everybody? This is going to be Chem Quest 39. I'm a little bit behind on these uploads, so let's get right into it. Stop wasting time. Okay, so Chem Quest 39, molarity. This shouldn't be too hard. Molarity, molality, you're just plugging, chugging. Okay, so first before we get into the questions, let's just find out what like molarity and molality is. Mr. Lee said we don't need to do one through three, so we can just plug that out. So molarity is uh moles of solute over liters of solution. And then molality is moles of solute or kilograms of solvent. And just a quick refresher, solute, solvent, solution. Let's say you have let's say you have like salt, like right here. And then you have a thing of water here, a solvent of water, right? The solute is the salt that's going to go in the water, and then the water is a solvent. And then combined, the salt plus the water is going to be a solution. Just a quick way to like know what's a solute solvent. Like the thing that's going in the water, it's solute because it's soluting. It's like saying goodbye. You know what I mean? So it's like so anything that's being dissolved, the thing that's being dissolved is a solute. All right, cool. Let's get right into it. Number four, verify that I need 2.15 moles of CaNO3 to make 358 milliliters of a 6 molar, my bad, 6 mole solution. So this is just what's molarity. You just finding out what molarity is. Molar is also another way to say molarity. So molarity is right moles of solute over liters of solution. So here we have the moles of solute. So it's going to be 2.15 over liters of solution. But this is milliliters. To convert from 3 milliliters to liters, we divide it by 1,000. 358 divided by 1,000 is 0.358. It's going to give us 6 molar solution. This is just one of those verifying problems. So yeah, a quick way to convert between milliliters and liters is to just if it's milliliters, you just move the decimal place three times to the left. So let's say it's 358. You move it, the decimal place is right here. You move this is in milliliters to convert it to liters. You just move it 3 decimal places to the left. So it's 1, 2, 3, 0.358. All right, cool. Verify that it takes 80.8 grams of sodium chloride to make 425 milliliters of a 3.25 molarity solution. So one other thing too, molarity is big M, molality is small m. So the way to push this problem is that there's 80.88 grams of sodium chloride, but for molarity, we need moles of the solute. And so in order to go from grams to moles, you need to do a little bit of stoichiometry. So we have 80.8 grams of NaCl, right? NaC the the mole whatever thing I can't even know the the ratio I don't know what the name is. Gosh, is mole something. It's just adding the things together. So Na is let me check it out. Periodic table. Periodic table, periodic table. Okay, so Na is right here it's 22.99, and then Cl is 35.453. So 22.99 plus 35.453. So give us 3, 4, 1, 14, 7, 8. So the mole something, I forget what it's called, 58.443. But I assume you guys know what I'm talking about. So to get to moles, you divide this out, you're gonna get 1.38 moles. And so same thing for molarity, you just divide 1.38 moles of solute over the kilograms, the liters of solvents. In this case, it's 425 milliliters. You do the trick where you move it 3 decimal places. So 0.425, and this will give you 3.25 solution. All right, let's go. Number 6, consider 670 milliliters of a 4.1 molarity solution of MgNO32 setting in a beaker. If you evaporate all 670 milliliters of solution, how many grams of solute would be left in the beaker? Right, so in this case, we have the molarity and we have the milliliters. So if molarity is moles of solute over liters of solution, we can just plug this in because what we're missing is the moles of solute. So it's 4.1 equals our moles of solute, which you don't know. Sorry, it says grams of solute would be left. How many grams of solute? We don't know our solute over liters of solution. You move 3 decimal places to the left. 1, 2, 3, 0.67. So you multiply both sides with 0.67. You're gonna get 2.747 grams of moles. How about moles of Mg NO32. You have the grams over mole. What's the thing called? Molar mass. Okay, so yeah, molar mass. Let's find out the molar mass. We should. Oh, that's cool. Oh, okay, so Mg is actually no. I'm not. Yeah, so just to find the molar mass, I'm gonna skip this a little bit. You just add up all the molar masses together. Um, so one one mole of or so moles or grams of moles, there's gonna be 148.33, and then grams over 1 mole. You divide this, you multiply this, you're gonna get 407.5 grams of MgNO3. Okay, moving on. Number 7, consider a solution that's prepared by adding 1.34 moles of sodium nitrate to 2.5 kilograms of water. What is the molality of the solution? Right, so this is just plug and chug. We have our moles of solute, right? In 1.34 over our kilograms of solvent, 2.5. Divide this out, you can get 0.536 small m molality. Number 8, consider the data given in question 7. Is this enough data to find the molarity? If so, calculate the molarity. If not, explain why not. So this is actually not enough information. This is because molality is different from molarity. Molality has kilograms of solvent, right? But molarity has the liters of solution, and solution and solvent are two different things. So I would put no because solution isn't given. All right, number nine, what is the molality of the solution that is made by dissolving 32.6 grams of Na2SO4 in 475 grams of water? So first, we need to find we have grams of solute, right? But we need moles of solute. So we just 32.6. This is gonna give us we have to use molar mass, grams of Na2SO4. The molar mass of sodium sulfate is 42, is 142, 2. Divide this out, it's gonna be 32.6. It's gonna be 0.2229. And then we have we have grams of the solvent, but we need kilograms of the solvent. So to go from grams to kilograms, it's same thing for milliliters to liters. We move it 3 decimal places to the left. So 1, 2, 3, 0.475 kilograms. You divide this out, 0.229 divided by 0.475. You're gonna get around 0.48. Small m. Okay. Number 10, consider 2.35 moles of sodium chloride that are dissolved in 1.21 kilograms of a solution to make 1.29 liters. Calculate and compare the molarity and molality. Let's do molarity first. So molarity, right, as you said earlier, is moles of solute over liters of solution. So here we have the moles of solute, 2.35 over liters of solution, 1.29. We get 1.94 m. Okay. Okay. Aber. Oh yeah, so you did. Sorry, my dad just left. Okay. And then that's gonna be our molarity. And then for molality, it's liters moles of solute 2.35 over kilograms of solvent 1.21. You get 1.82. 1.821. Small m. Okay, number 11. If 26.45 grams of Na2SO4 dissolved in 1.1 kilograms of solution to make 1.24 liters, calculate both the molarity and molality of the resulting solution. So for right, we need moles of solute, but we're given grams. So to go from grams to moles, right? It's gonna be molar mass. Grams of Na2SO4. We found out earlier that the molar mass of Na2SO4 is 142. So 142. You divide this out, it's gonna be 0.186 moles. And then to find the molarity, you divide the moles of solute over the liters of solution. So 1.24, 0.186 divided by 1.24. You get 0.15 molarity. And so for molality, it's still moles of solute, which is 0.186 divided by kilograms of solvent, which is 1.1. What did I do? What the heck? Yeah, 0.186 divided by kilograms of solvent. You get 0.169 molality. I think, right? Yeah, because kilograms of solvent. Yeah, what? Why am I doubting myself? Okay, I did it wrong on my worksheet before. Okay, so yeah, moving on. Number 12, prove that the mole fraction of salt equals 0.049 when 14.25 grams of NaCl is dissolved in 85 grams of H2O. So this is yeah, so this mole fraction thing, if you're trying to find solute, then you put solute on the top. If you're trying to find solvent, then you put solvent at the top. And then you just add solute plus solvent at the bottom. So same for both of these. Okay, cool. 12, right? The mole fraction of the salt is 0.049. So we're trying to find the mole fraction for the solute when 14.25 grams of NaCl is dissolved in 85 grams of H2O. So in the formula we need to use moles, but we're given grams, so we need to convert grams to moles. So 14.25 grams of NaCl divided by 58.43 grams of NaCl equals 0.243 moles. And then NaCl, and then 85 grams of H2O. The mole ratio, the molar mass of this is going to be 18.016 grams. Divide this out, it's going to be 4.71. So for plug and chug, right, it's a solute 0.243 over 0.243 plus 4.71. And this is going to be 0.049. All right, so 13. Find the mole fraction of water for the solution described in question 12. So same thing, but just finding it for the solvent, right? Solvent is going to be 4.71 divided by 4.71 plus 0.243. Because right, the solvent this time is the water. And then that's gonna be 4.71. You divide this out, it's gonna be 0.95. Mass percent composition. This is just the same thing, right? Just if you're trying to find solute, then so yeah, for solute, if you're trying to find solute, then you put the solute on top. And for the denominator, it's just solute plus solvent. But this time it's mass, so you're gonna be using grams. And then you multiply by 100. So yeah, let's get right into it. 16, prove the mass percent of salt is 14.36% in the solution described in question 12. So we're using question 12 now. So we use the grams. So we're trying to find the mass percent of salt to the solvent. So the grams of salt was 14.25 divided by the grams of H2O was 85. 85 plus 14.25 is 0.14. But then you take this and you multiply it by 100. It's gonna be 14.36%. Number 17, calculate the mass percent of sodium phosphate if 12.5 grams of it are dissolved in 250 milliliters of water. Note 1 milliliter of water has a mass of 1 gram. So we're trying to find the mass percent of sodium sulfate, 12.5 grams on top, divided by this, it's going to divide by 12.5 plus the grams of water though. We don't have the grams of water. We only have the milliliters of water. So to convert from milliliters to grams, it's given here. 1 milliliter of water has 1 gram of water. The 250 milliliters, 1 milliliter of water has 1 gram of water, and 250 grams. So plus 250. You divide this out, it's gonna be 4.7. Oh, it's gonna be 0.0476. And then you multiply this by 100, you get 4.76%. Okay, cool. Yeah, that's gonna be the chem quest, I think 39. Yeah. Happy studying, guys. How do I